All right, let's finish up our quadratic transformations today, where we're going to be looking at all the transformations that a quadratic function can make. So we're going to actually sketch some from the function, now that we've kind of identified the ones that we use the most, okay? So let's go ahead and take a look at what is happening, like what's the transformation that is happening on x squared plus 6. So if you remember back to yesterday, we talked about horizontal shifts, vertical shifts, reflections, and dilations. Okay? The three we worked on yesterday were mostly these three. So horizontal shift, vertical shift, and a reflection. So which one is this first one? Well, this one, x squared plus 6, this is a vertical shift, okay, which means it's going to go up 6 spots. Or a VS plus 6, okay? It's going to go up 6. So if I was to sketch this, 1, 2, 3, 4, 5, 6, there's my point. It's up there. Now the difference is this one has parentheses. And if you remember the parentheses, this was horizontal and it was opposite. So this one would be, the opposite being negative 6, it would be a horizontal shift to the left 6, or HS negative 6. Okay, HS negative 6, which means I'm going to the left. Okay, now let's take a look at these two. So both of these have negative 3. So I know that the negative is going to be reflection. I know that this minus 4 is a vertical shift down of negative 4. Who remembers what the 3 does? Well, the 3 is a dilation. Now remember, there was two types of dilations. We had, if it was a whole number greater than 1, that was going to make it skinny. And if it was less than 1, that was going to make it wide. Okay? So is this one going to be wider or skinnier? Yeah, it's going to be skinny or narrow. So this one actually has 3. It has a reflection. It has a vertical shift down of 4. And it has a dilation that makes it skinny. All right, what about the next one? Well, 2 of them are going to be the same. I see that it has this and this that are the same. So this is still going to reflect, this is still going to dilate. So I still have a reflection and I still have a dilation that's still going to be skinny. And if I remember, this one, it has to be opposite. So HS plus 4. So a horizontal shift to the right of 4. Okay, so now let's take a look at this new form of the quadratic that we're talking about. So this is actually the vertex form, okay? And so what we're going to do is put all these transformations together today into this formula, okay? So that we actually have each of these variables has a job. The A has a job, the H has a job, and the K has a job. And it happens to be that our vertex is HK. Okay, that's our vertex. So when we look at our vertex form, every single variable other than the X has a job. Okay, has a job. So let's take a look at our first problem here. So we've got f of x equals a quantity x minus h squared plus k. And here's my example, 4 x minus 2 squared, quantity squared plus 2. Okay, so we need to kind of figure out what each of these jobs are. So this first one, the number, that's a dilate. And is that going to be wide or skinny? Well, that's a whole number. So that's going to be dilate skinny. So I know that I'm going to be creating a skinny graph. Okay. Now, I've got 2 pieces here. This one is inside of the parentheses. So I know inside is horizontal and it has to be the opposite. So what is the opposite of minus 2? It's plus 2. So horizontal shift of plus 2 means I'm going to the right. Okay. Now outside the parentheses, that's a vertical shift, which means I'm going up 2. So vertical shift up 2 is my second motion. So that tells me kind of a quick sketch of what this is going to look like. So first of all, I know it's a smile because A is positive. Okay, there's no reflection here. So it's going to be a smile. So then to be able to identify my vertex, I'm going to start at 0, 0, and I'm going to do the motion. I'm going to go right 2, and I'm going to go up 2. So my vertex has moved from 0, 0 to 2, 2. And I know that I'm skinny, and I'm a smile, and I'm done. Okay, I'm done. We obviously know how to find all the other characteristics, but for our purposes, when we're talking about transformations, we're usually using vertex form, and we're just pulling what are the basic meanings of the numbers there. Okay, let's look at this one. So I see 4 things: 1, 2, 3, and 4. Okay, so let's start on the right side. So this one is a vertical shift down 3. So I know I have to go down 3. This one is a horizontal shift left, -6, because remember, this one is the opposite. Now this one is dilate, and it's going to be skinny because that's a whole number. And then I have a reflection. So I know that my graph needs to be upside down. So let's make the motion. So it says I have to go left -6 and down 3. 1, 2, 3. There's my vertex. Okay, so my vertex is -6, -3. That's my vertex. And I am skinny and I'm upside down. I'm skinny and I'm upside down. Okay, let's see what we can do with this one. So 2x² - 3. Well, this one's a vertical shift. I don't see any horizontal. So horizontal is 0. There's nothing. This one is a dilate. Skinny. Is that it? Yeah, there's just 2 on this one. So I know that I am going down to -3. There's my vertex. So my vertex is 0, -3, because there was no horizontal shift. I know that it's skinny, and I know that it's a smile. All right, what about this one? This one doesn't have anything there really. So there's no dilation. All this one has is an HS plus 5. So I've just moved my vertex over here. And this one is just normal. So normal is kind of like just in the middle. When you're talking about making something wide, make it wide. Like really clearly make it wide, clearly make it skinny. What we'll notice as we work is that the bigger the number, the skinnier the problem. Okay, so for example, if I give you y equals 3x² and y equals 10x², this one is, so if I make this one purple, so 3x² might be like this, whereas the 10x² is much skinnier. Okay, so the bigger the number, the skinnier the parabola will be. Okay, and the smaller the fraction, the closer to 0, the wider it will be. All right, so let's see if we can figure out this equation of the graph. So this is actually a multiple choice. So let's think about what the transformations are here. So I see a reflection. So I know I have to have a negative. I see a horizontal shift of +3. So if there's no vertical shift, then I know I have to have parentheses. So it can't be these two. Okay, it can't be because I don't have parentheses. I have to have parentheses if there's a horizontal shift. So is it going to be C or is it going to be D? Which one shows this horizontal shift? Well, hopefully you said D because it has to be the opposite. Okay, why don't you hit pause, see if you can figure out these 2 multiple choice questions. Okay, so which function includes a translation of 3 units to the left? So that would be HS -3. So which one of these has an HS of -3? Well, this is a vertical shift, so that one's out. That one says -3. That one's a vertical shift, so it has to be either A or C. Well, remember, Has to be opposite. So the answer is A. Okay, now this one says which equation shows a translation of 3 left, so an HS left of 3, and a vertical compression. Okay, so vertical compression, that means it has to be skinny. And it says the factor is of 2. Well, I see 1/2 and I see 2. Well, 1/2, those are wide, so these are out. So which one of these has a horizontal shift of 3 to the left? Yeah, opposites. So the answer would be B. Okay, so see what you can do with your homework today. Reach out to us if you're struggling. Remember, you can use your Desmos graphing calculator to kind of type in the functions and kind of take a look at what's happening between the graphs. So for example, if I want to compare, if I put in y equals x squared, and I want to compare y equals -2 x squared, I can put those in and take a look at what happened between the first one and the second one. And so sometimes if I can't really figure out what the function is doing and I need to like graphically look at it so I can kind of figure out what's going on, you can do that. Okay, so make sure and keep your Desmos graphing calculator open to help you as you need to. All right, well, we're done with this chapter. So we will be doing a little bit of review tomorrow and then moving on to our exam. Reach out to us if you're struggling.